Hey kiddos, today we are going to be talking about exponents and our introduction to different exponent rules. So the first thing you have to remember is that an exponent is that little number that's floating on top of the regular number, which we call a base. Okay, so here you have a base of 5 and your exponent is 9. So when you're looking at exponents, the way we read them is a little bit different. For example, you have here a base of 6 and an exponent of 4. So you would call this 6 to the 4th power or 6 to the 4th. We don't say things like 6, 4 because that's more of like someone's height, but 6 to the 4th is what we would say here. Okay. Now, in order to simplify, we always have to think about what it means when we have exponents. So here, for example, I have 8 to the 3rd power. And what that means is I'm taking the number 8, which is our base, and I'm multiplying it by itself 3 times. So here I would have 8 and I'm multiplying it by itself 3 times. So 8 times 8 times 8. And then when you have a numerical base, you can get an answer for that. So for example, here 8 cubed or 8 to the 3rd power is 8 times 8 times 8, and that gives us 512. Now, sometimes we're working with numbers, other times we're going to be working with letters. And so when you're working with letters, you're not going to actually be able to simplify that way. You're just going to have the letter as the base and then the exponent. Okay, so let's look at some examples. Okay, so that first one, we have 3, 3, 3, 3. So we have a base, of course, of 3, and there's 4 of them. So that is going to end up being 3 to the 4th power. And if I wanted to simplify that, 3 to the 4th power could be written as 81. Now here we have a letter base. We have a base of A. There are 1, 2, 3, 4, 5 of them. So that's just A to the 5th. And that would be the final answer on that. Here you have B, C, and they're in parentheses. So what that means is we're going to keep the parentheses around the BC. So we have B, C, and there's 3 of them. So 1, 2, 3, that'd be BC cubed. So whenever you have the parentheses around, you're just going to keep those, and then you're basically writing how many of those groups that you have. So when we're finding actual values, the thing we got to be really careful with is when we have negatives. So depending on the location of the negative, we have to think about what that means in terms of order of operations. So we have a couple different examples here. We have 3 different examples. The first one, 7 squared, there's no negative here, so that literally can just be written as 7 times 7, which we can simplify as 49. The second example, we have our negative on the outside of the parentheses. So if we're thinking order of operations, this would be the negative is going to stay outside of the parentheses. And then we have 5 cubed, which is 5 times 5 times 5. Okay, so we're going to simplify what's inside the parentheses. 5 times 5 times 5 is 125. But that negative from the beginning is going to follow along, so the answer would be negative 125. The third example is different because the negative here is inside the parentheses. So here you have negative 3 4 times. So we have negative 3 times negative 3 times negative 3, and then 1 more. So here we have to think about all the negatives and how they affect one another. So here I have negative times negative times negative times negative. So if we're thinking about 2 negatives make a positive, this goes negative, positive, negative, and back to positive. So our final answer will be positive. And then I have 3 times 3 times 3 times 3, and that gives me positive 81. The last example is kind of like a repeat of this one up here, just an additional practice. Again, I have a negative on the outside. 2 to the 5th means 2 times 2 times 2 times 2 times 2. So if I'm doing what's in the parentheses first, that would be 32. And then I have the minus sign, which tags along. So the final answer would be negative 32. So pretty simple. The negative is on the outside, it tags along. If the negative is on the inside, then you multiply with the negative. Okay. Now, we're going to be going through exponential versus expanded form. So these are the two forms that we have. Knowing the difference is super important. So expanded form is when you have things written out, full, all the bases are written out. And then exponential form, you just kind of count up how many of each base you have, and it's a condensed form. So it's super easy to look at exponential form. It's much more helpful than looking at expanded form where you have all the terms kind of written out. Okay? So we're just going to practice converting between the two different forms. So our first problem, we have 8s, we have x's, and we have y's. So looking at the 8s, okay, I have 2 of those, so I'm going to do 8 squared. I don't have to change that to 64. I could leave it as 8 squared. Then I do my x's. I'm just going in alphabetical order. So if I have multiple letters, I'm going to go alphabetical order. So I have x and x, that makes x squared. And then I only have one y, so I write y, and I like to put the 1 here, okay, because I want to make sure I know I have an exponent there. Second example, again, start with numbers. So I have 1, 2, that's 2 to the first power, there's only one of them. Then I have 2 a's, that's a squared. And then I have 1, 2, 3 b's, so b cubed. Again, just really simple, you count up the number of bases that you have. Okay, so this problem here, 13 is one of our bases. I have one of them. Then I have 2 p's, so p squared. Then I have, 3 p's, so p cubed, easy to change that. And then I have 2 r's, so that's r squared. Okay. Next problem, I have 1, 5, so 5 to the first. And then I have 3 x's, so that becomes x cubed. Last problem, 4x is in parentheses, so again, I want to keep it in parentheses. And I have 3 of them, so 4x quantity cubed. Okay, so it's really easy to think about how to do these problems. You're looking at the different bases you have, and you're just counting up how many of each one that you have to write it in exponential form. Okay, so we have 2 more examples. These problems are a little bit longer, but still the process is exactly the same. So for our first problem, we're starting with our numbers. So we have 2, and there's 3 of them, so that's 2 cubed. Again, I don't have to change this into 8. I can just keep it as 2 cubed. Then alphabetical order, I'll do x's, 1, 2, 3, 4, 5. So that's x to the 5th power. And then y's, 1, 2, 3, 4, 5. So that's y to the 5th power. For our last problem, we have this negative sign here. So we got to be really careful. I want you to think about the negative sign as its own individual thing. Okay, so I have 1 negative, so I'm going to write that down. Now remember, if there were 2 negatives, that would be a positive. But because there's only 1 negative, the answer stays negative. So really, you can think about it, if there is an even number of negatives, then the answer is going to be positive. But if there's an odd number of negatives, so if there were like 3 negatives, then the answer would be negative. Because there's only 1, the answer is negative. Then I think about the numbers. 3 and 3, that gives me 3 squared. Then I have alphabetical order. I have A, 1, 2, 3. Then I have B's, 1, 2, 3, 4. And then I have C's, 1, 2, 3, 4. So C to the 4th power. And essentially that's all you're doing. You take the different bases, you write them down, and you just count up how much of each base you have. Super simple.